So today we're going to look at Unit 4, Lesson 1, Part 3. This is the application problem. So for our first example, we're going to be looking at the final example from the PDF notes. Find the tangent line and normal line to, here's our equation, at the point -1, 2. So the first thing we need to do is understand that we are being asked to complete two different lines. The first is the tangent line and the second is the normal line. So I'm going to start with the tangent line over here. Okay, so when we go to find the tangent line, okay, anytime they talk about the tangent line, your brain should automatically say, oh, tangent line is going to require the slope. The slope of the tangent line is found by finding the derivative. So the first thing I need to do is I need to find dy dx. Okay, so we're going to start with tangent line. So I'm going to take my equation that I have here, and I'm going to recognize that it consists of two variables, both x and y. So I'm going to take, and 2x is my derivative of x squared, minus, I'm going to have to use a product rule. Notice how I've written my product rule, where I subtracted the product derivative, plus 2y, notice I'm attaching the dy dx, is equal to 0. So now I'm going to go back in here and I'm going to do my product rule for this. So I've got x times the derivative of y, which is dy dx, and then I've got y times the derivative of x, which is 1. Okay, now if I clean this up a little bit, 2x minus x dy dx, distribute the negative here, minus y, plus 2y dy dx equals 0. This is what I have. Now, one of the things that I like to do is I like to isolate both my dy dx terms on one side, move everything to the other side. So over here, I'm going to get a positive y, subtract 2x, and on the left, I can take the two terms that I have a circle around, and I can GCF dy dx out front. From here, I'm going to divide both sides by my quantity. And now I have my derivative. Dy dx is equal to y minus 2x over negative x plus 2y. Right? Now, let's think about what we've generated. We have generated a new equation that if we know the x and y values, when we plug them in, we can always find the slope of that tangent. So the second thing I'm going to do here is I'm going to plug in my xy value. Okay, so I'm going to come over here and I have, this is my x, this is my y, and I'm going to say 2 minus 2 times negative 1, all of which is over negative 1 plus 2 times 2. Right? So I've plugged into here my x and y values. So I end up with 2 plus 2 up top, which is a 4, over 1 plus 4, which is 5. This is my m. I have my point, negative 1, 2, x and y, and I have my slope, 3. I'm going to use those things and put them into my point slope. So my point slope is y minus y1 is equal to m x minus x1. So I take this information and I say y minus 2 is equal to 4/5 x plus 1, because I'm going to subtract the negative 1, and I'm done. Okay. Now remember, this is this equation for the line that is tangent. When we want to talk about the normal line, I'm going to put two arrowheads over here. The normal line stays the same. 1 is still the same, so I'm going to find dy dx. All right. Number 2, I'm still going to plug in xy. However, there's a 2b step involved for normal line. By definition, the normal line is where I would take my curve. I would have my slope, which is the tangent. The normal line is going to be perpendicular to the tangent. So I'm going to have to take, and I'm going to have to say m perpendicular is equal to the opposite and the reciprocal, 5/4. Then I'm going to use that with my point, -1, 2, plug it into the point slope form, y minus 2 equals -5/4 x plus 1. Everything stays the same about point slope. We're just going to be using the perpendicular slope, not the tangent slope.